about 30 seconds to start. I'm going to get started. I can see it's still full. Okay, the class is definitely still full. I think we still have more than 44 students, which is the capacity of this class. Not the classroom, but I can only handle like grading and stuff like that, for the class of 44, and not 45, and not 43, 44, just to be exact. Okay, so last time we started on the topic of what makes a programmer. Okay, let me just kind of point out where we left off last time. We started on this slide here. And last time we were talking about this this was the very last thing that we talked about. There are challenges of becoming a programmer. There are three main challenges. The first one is to learn, programming languages, not a single programming language, but programming languages. Fortunately, a lot of programming languages are related. If you know how to program in C, C++, Java will be pretty easy to learn. Perl should be pretty easy. PHP, should be pretty easy. And that really is a part of, you just need to use it enough, then you feel familiarized enough, and you should not have a problem. The second part is programming logic. You have to focus on a lot of details. So I would just kind of highlight the portion that I'm talking about. You need to pay a lot of attention to details, and logic, is the key of programming. The last one is really the most difficult part of becoming a successful programmer is the process of debugging. The process of debugging is a diagnosis type of process. You're given the symptom, the program is not working the way it's supposed to, but your job is to figure out, one, why is it not working the way it's supposed to, and two, given that, how do you fix it? Okay, so that really is the most challenging part of becoming a developer, is to find out what is wrong with a program and then figure out how to fix it. But surely we don't have any programs that need fixing, right? I mean, how do you call Tuesday from Microsoft's perspective? Patch Tuesday, right? Microsoft always release their major patches on Tuesdays. So it's usually on a Tuesday that they accumulate a whole bunch of patches, and then on Tuesday you can basically go to Windows and click Windows Update, and then you can download a whole bunch of patches. I think if there are more urgent ones, you can probably get your patches earlier than Tuesday, but most of the time they schedule that on Tuesdays. Even with Linux, we have patches on a daily basis. Because given the number of programs and software that I install, I always have something to patch. On the average of maybe 50 or so packages of updates on a daily basis. So that really is a big job, a big chunk of becoming a developer. So are there any questions at this point about what it takes to become a good developer, an effective and successful developer? And until somebody can become an effective developer, becoming a software engineer or a computer scientist is really kind of out of the question, because this really is the basis of programming and computer science. So until someone can actually handle this kind of work, becoming a higher level type of person in terms of computer career is very difficult. Any questions at this point? No questions? All right. So we're going to move on and continue to talk about, have we talked about algorithms and pseudocode in this class? Nope. Okay. So let's start with algorithms. I kind of, we talked about this. Yeah, I think we talked about this. Have we talked about pseudocode?
Briefly.
Okay, we talked about that too? All right. So that means we are done with this particular module and we are moving on to topic 2. Before I move on, what I'll do is I'm going to highlight topic 2, so this way we know that we are moving forward to the next topic. So topic 2 is now our current topic. I just need to click the light bulb here to make it, our currently highlighted, topic. And don't forget there's a homework assignment that's due on Thursday. Okay? So you might want to double check and make sure that you know there's a homework assignment that you have done, and you will have it done before the due date. Okay, topic 2 is starting to get into the real topics of programming. How do you write programs? And we'll start with something that is relatively simple. So this is what I usually do every semester, but I think I need a new example because people don't do this anymore. How many people still get your credit card bill through your physical mail? Okay, that's more like a habit, right? We just haven't switched over to the paperless type of bills. And how many people balance your own checkbook manually? Not using a spreadsheet, but manually, using a book. You still do? Okay, very good. So one person in this class knows this whole process. The rest of us read this and go like, wow, people actually did that? It's not a bad thing to do, because it is entirely manual. So that means if the computer fails, if the network fails, you will still be able to kind of figure out how much money you have, and you don't need to rely on technology. And it's also much harder to get hacked, because if people hack into a bank system, they can basically mess up things, and it's really hard to realize unless you check item by item and say, yes, I did make this purchase. Wait, this one here I did not. I cannot figure out what it is. Then you can spot something is wrong with your with either your credit card bill or your bank account balance. But doing something manually can give you an idea of whether something is wrong or not with your bank account or your credit card bill. Okay, so this is what people used to do. They receive a credit card bill by mail, and then let's assume that the balance for that particular month is X dollars. Okay, and in this particular example, I am assuming that this person is going to pay off the entire balance, which is a good idea to begin with. Why? Because otherwise you'll be starting to pay interest. And how much interest do we pay for an average credit card these days? Sorry? 18% per year, right? So that's the annual interest. And interest is it compound or is it, what's the other one?
Fixed.
Fixed? It compounds, right? So that means, if it is 20% per year, so we'll just kind of round it up to 20%. In 2 years, it will effectively become what? 44%, because 1.2 times 1.2 is 1.44. So that means whoever is paying off that debt or that bill will have to pay 44% on top of the amount that is actually quote unquote borrowed. So it's always a good idea to pay off the credit card bill. Okay, so we are assuming this person is paying off X, the entire credit card bill, and we are assuming that the amount or the balance is X dollars. Why do you think I use X here instead of 23, 16, 300, whatever?
Because it varies?
Because it varies, because it changes, okay? So the credit card balance for this month may be different from the next month, and so on and so forth. So I'm just using X here as a name, so later on I can refer to the same amount for the calculations. So one thing that person will do, back in those days, is to write a check of X dollars and send it to the credit card company. Whenever you get your credit card bill, by mail, they always come with a little envelope, and then the bill itself has a detachable portion where you can just write down, I'm paying this much money out of my balance, and then you attach your check, put it into the same envelope, seal it, and then send it off. So I'm assuming that this person is going to pay off the entire balance. So therefore, that person will write a check of the same amount to the credit card company. Do you think that X of the first line item and the X of the second line item refer to the same thing, or they have no relationship whatsoever? I'm trying to express that they are exactly the same thing, and that's why I use the same name, which is X here. Without using X, what would a normal person do without a programming or math background? They will have to be a little bit more verbose, right? Write a check of the same amount as the balance of the credit card bill, and to the credit card company. But by using the variable name X, I can just now refer to variable X or X amount. Then I don't have to be very verbose. What if you have multiple credit cards and then you have a lot of different cards? Then you have to be even more specific. But having just the name X makes it very simple to refer to that amount. And in the third line item, we are going to deduct X from available funds. Available funds is basically your way of tracking how much money you have left in your checking account or your savings account. Okay? In the good old days before online banking, people actually have a book to write down their deposits and also withdrawals. So every time you get a paycheck, you deposit your paycheck and you add that much money to your balance, and then when you pay a bill like this, then you deduct the same amount from your balance. So in this case, I'm deducting X from available funds, which is reflecting how much money I have in my bank account. And for people who want to track how much money they spend through a particular credit card, they can also add X to the annual total expense for a particular credit card, because some people may have a credit card just for gas, like a Shell or Chevron type of a credit card, so they can easily keep track of how much money they're spending on fuel. So that's how that person wants to do everything. So we want to use this particular example to illustrate three main concepts. One is what is a variable. Two, what is an assignment statement. And three, what is a sequence. Okay, so those are the three things we want to illustrate using this particular example. Before we move on, are there any questions about these four steps that people used to do by hand whenever they pay off their credit card bills? Yep.
Not as much to do with algorithm, but when people were doing this, weren't they using cash a lot more than they were using like debit cards compared to today?
They might be using cash more, but having a credit card is convenient because you don't have to carry as much cash. And some people, but these days, okay, some people may think, if I use cash, then it's hard to track, right? Because cash is cash. But the interesting thing is people actually keep track of, bills, okay? Dollar bills, $10 bills, $20 bills, because each one actually has a number on it. And I think every time it changes hand or every time it gets to a bank, they scan and actually keep track of the how a particular bill moves through the system. In fact, just for those of you who are interested, you can. What is the name of that website? Where's my dollar bill? Well, I think this will get it close enough. Track your dollar bill. There you go. Where's George?
That's right.
But because of technology, I think these days, spending, money in terms of just using dollar bills is actually, pretty trackable too, especially the bigger ones. The bigger bills are definitely being tracked. So the bottom line is you have to use quarters instead of dollar bills, because quarters are not trackable. They don't have any unique numbers on them just yet, to track individual quarters. So when you want to go buy a car, then you bring in, let's say you're buying a $10,000 car, so we bring in 40,000 quarters to buy that car. But then nobody can track that you have just spent that much money to buy a car, ever. Except for everybody who's looking at you hauling in 40,000 quarters to pay for your car, and then they will all be taking pictures of you with your 40,000 quarters, and then posting it online on Facebook. So before you even get out, driving your car, the picture of you purchasing the car, that video is going to go viral. There goes the intractable, not being possible to
There
track.
was a gentleman who recently had to pay some court fines or something, and he did that. He paid about half, pennies or something. He did like half the fine or whatever it was that he was dealing with in court. He did that. The court wasn't too happy. They didn't know what to do with it.
I heard a guy.
Oh no, he was paying the other people or something. It was a lawsuit or something.
I heard a guy took a bunch of $1 bills, folded them to little pigs, and put them in donut boxes, and delivered that as a fine.
Well, people do that, huh? All right, so getting back to our example here, the first concept we want to illustrate is the concept of a variable. We actually have a few, but the most obvious variable in this entire example is x. Okay, x is a variable because it changes. Depending on which bill and which month you're talking about, that amount changes. All right, so let's take a closer look at what a variable is. A variable, as the name implies, is an object that can hold a value, and it has for the following attributes. We'll focus on only two of them, at least for the time being. The first part is every variable has a unique name. In other words, if you are using multiple variables in any type of algorithm, each one must have a name that is different from all the other names. So this way, when you mention a variable, it is not ambiguous. You know exactly which variable we are talking about. So in this particular case, if I use variable x, that can only be one variable x in the context of this code. So that's the name. And then the second part that is important is the value. I'm skipping the type for the time being. The value of a variable is the part that can change about a variable. The name of a variable cannot change. Okay, once you designate a name for a particular variable, the name sticks forever. But the value can change. The value is also known as quote unquote the state of a variable, and it can change. If you look at a variable as a coffee mug, then the label on the coffee mug to distinguish this coffee mug from all the other coffee mugs is the name of the variable. Okay, it helps you identify which one we are talking about. The content inside the coffee mug is the value, because that portion can change over time. The variable itself is still the coffee mug, it's still the container. The container itself is still the same throughout the entire algorithm. But how much liquid it contains can change over time. Is that working out okay? So that's basically what a variable is. Now we get back to type just a little bit. I don't want to spend too much time on type because at this point it doesn't really change too much of what we are doing. It doesn't impact what we are doing. The type of a variable, if we use the coffee mug or container example, means if you have a coffee mug, it can only contain coffee. If you have a wine glass, it can only contain wine, okay, and so on. In other words, you can only put certain types of liquid in a certain type of container, and you cannot, cross. But it is not important to us at this point because we'll only be using numbers and numerical values for the time being. The rest of this is really helping us to identify our variables in the example. X is the obvious one. We talked about that already. But there are other ones. Available funds is also a variable because the balance of your bank account, how much money you have in your checking account or your savings account, changes over time. When you deposit money, it increases. When you withdraw money or pay your bills, it decreases. So therefore, available funds is a variable itself, and so is your total expense for a particular credit card. So if I use American Express as my credit card, AE total expense in double quotes in here because I use it as the name of the variable, that becomes a variable because every time I pay off my bill, I'm going to add more to the annual total expense, which is a variable. Are there any questions about this slide, the concept of a variable? questions? All right. So now that we know what a variable is, let's try to figure out what we can do with variables. So we'll go ahead and skip this part first, and we'll talk about assignment statements in general, and then we'll go back and look at our example. An assignment statement is a step that updates the value of a variable. This is the most basic way to update the value of a variable. Okay, the general form of an assignment statement in this class is LHS, which stands for left-hand side, gets the result of the RHS, the right-hand side. Okay, and I use a left arrow in between to indicate that the value of the right-hand side is used to update the variable specified on the left-hand side. Okay. And the fact that they are in italic, because LHS is italic and so is RHS, means that these two are quote-unquote placeholders. In other words, they have to be specified in order for an assignment statement to be useful. They're basically just placeholders in this representation. This is a general meta syntax or meta grammar, if you will, that you will see in all of your other programming classes. When we try to specify syntax of a programming language, you need a particular way to you need a particular notation to express the syntax of a programming language. And this is usually how some people do it. Italic means it is not verbatim. It is not what you have to type. It is going to be substituted by something else. The left-hand side specifies which variable to update. And okay, this part we talked about already. The symbol, which is the left arrow, is usually replaced by a single equal symbol in most programming languages. Okay? If you have written programs for a long time, it seems natural and say, oh, that's the right symbol. That's the way it is supposed to be. But that actually is not the case. So I'm going to use a text editor here as my little whiteboard. And what I'll do is I'm going to show you why it really does not make sense to use a equal symbol to represent assignment. I'm going to change the font size first. I just have to find out where to go to change it. Do you see the font change?
Select font under view.
Under view, select font. That's it. Thank you. So let's make a pretty big one like this. Okay, so we'll go ahead and talk about this x equals 0. In the context of a mathematics class, what does that mean? Okay, it has two potential meanings. One, it is asking, is it true or is it false that x equals to 0? Okay, just like, okay, x is greater than 0. Okay, it's usually not stating it is true, it is a question, is it true or is it false? Or in an assertion, it means x does equal to 0. Okay, it's telling you something about 0, or it's asking you a question about x, not 0, about x. Okay? Okay, but in programming, this has a completely different meaning. I'm using less than and the dash, less than and minus, to represent the left arrow. Okay, it is an assignment statement. Now, how are these two different? One is a comparison. This is a comparison. X equals to 0 can either be true or false. Okay, we're just comparing x to 0. Are they the same? Are we doing okay so far with that concept that x equals to 0 is usually a comparison? Is that okay? The second one, this is not a comparison. This is an assignment. An assignment means you evaluate the right-hand side and then you update the left-hand side. The left-hand side always has to be a variable because you cannot update anything other than a variable. Okay, so they are different. But the difference does not seem to make a whole lot of sense at this point. Okay, now this is a constant assignment operation, which means the right-hand side is nothing but a constant, a 0. Okay, it's a constant, it doesn't change. So that's pretty easy to understand. You know, this is what I usually do at the beginning of a year because I want to reset the total expense for my American Express card. Okay, so whatever it was before from the previous year, I don't care anymore. I'm going to reset it back to 0. I'm going to lose its original value so that it starts from 0 again. Okay, so that's okay. That's not a very difficult operation. I'm just resetting it. Are there any questions about this particular slide? No questions? So this operation is clear what it does? Okay, let's take a look at the next slide. The next slide talks about self-referencing assignment. What do I mean by self-referencing? This is an example. Okay, AE total expense gets AE total expense plus X. Okay, so this is where the equal symbol does not make sense anymore. Okay, let me switch back to my notepad here, and then we'll just express this thing like this. X gets X plus 1. If you ask your math professor what is X gets X equals X plus 1, what will be the answer from the math professor? Assuming your math professor has no programming background, so doesn't look at it from the programming perspective. So what would be the answer of this? Go ahead.
It's a wrong formula.
It's a wrong
Formula.
wrong format. No, it's okay. I mean, even in math, this is a correct format because you're comparing X to X plus 1.
X minus X equals 1.
X minus.
False.
Yes, that would be the right answer. False is the answer. Okay. If your math professor doesn't want to make fun of this particular expression, then your math professor will say it is false. It is always false regardless of what X is. Because if you have X on one side and you have X plus 1 on the other side, the two sides cannot be the same. And therefore, it is always false. Is that making any sense? Because to the math professor, we are not trying to do something to X. We are simply trying to compare the quantity X with the quantity of X plus 1. Okay? We're not changing anything. It's not an assignment operation. On the other hand, in a programming class, in this particular class, I use the left arrow to indicate assignment. This, on the other hand, is very useful. Okay, you will see throughout this entire semester that we have statements like this, throughout, our algorithm. This means we have to evaluate the right-hand side first. Evaluating the right-hand side means we have to evaluate this expression first. X always has a value. Okay, whatever value it has, we'll take it, we'll add 1 to it, it becomes a new value. Is that working out so far? Whatever that value is, we'll use it to update whatever variable is specified on the left-hand side. So effectively, what are we doing to the variable X? Adding 1 to it. We're incrementing X by 1. Are we doing okay so far with this statement? It is not cyclic. In other words, we don't think about this like, oh, but once we change X, do we have to reevaluate this whole thing because, it has changed? The answer is no, we do not reevaluate it at all. It's just a two-step process. Evaluate the right-hand side. Step 2, update the left-hand side. You're done. Move on to the next statement. Are we doing okay so far? Okay. So this is why I do not use a single equal symbol, because even though in a programming class I can say and emphasize and say in this class the equal symbol means assignment, I just do not like that notation to be used in this context because it really does not, it's not the same thing as a comparison, okay? But just because I don't use this notation in this class doesn't mean programming languages would not use it. So just about any programming language that you will learn in these days, like C, C++, Java, Perl, Python, and so on and so forth, Visual Basic, they all use a single equal symbol to represent our left arrow in this class. Yep, go ahead. Row sheet, thank you. I think just about everybody has this in at this point, so I'm gonna pass the row sheet. Just initial your name next to on the column of September 3rd. Okay. So are we ready to move on? Okay. Okay. So that means our operation, the entire operation, can be specified as a program. Okay, it can be specified as an algorithm. It's a two-line algorithm, not very complicated, but nonetheless, that's what we do. Because every time we perform the process that we just talked about manually, what we are doing is we are taking this amount, X amount of money from available funds, which is your checking account, and then we are adding that to the total expense because we are just adding it to the total expense for that year for that particular credit card. That's how it is expressed. And this is where I explain, the concept of a sequence. A sequence means, we perform one step, and then we perform the next step, and then we perform the next step. The ordering is potentially important. In this case, it is not. Okay, if you reverse the order of the operations, nothing gets changed. They will both get done also, without any problems. But in some other types of algorithms, changing the order of operations can change the behavior of the algorithm. In this case, it does not. But a sequence simply means we are doing things as ordered, by the line numbers. All right. Are there any questions at this point? Okay. The next one is, how do we visualize? How do we see the execution of a program? Okay. Now that one requires a little bit of explaining, and it's really important because this is how you will be doing your homework assignments. The way I explain and also visualize the execution of pseudocode is I use a spreadsheet for that purpose. I know it's an overkill, to do something like this with a spreadsheet, but it really is one of the best representation that I can think of, and this is how we do things for the entire semester. For those of you who do not like to trace programs because it is tedious, it is slow, and it's you just don't enjoy the process, well, you just have to do it for one semester because I think no other programming classes will teach you about tracing an algorithm by hand. Okay? And this is also why I do not teach this class using a particular programming language, because I don't want you to write the code and run it through the computer to figure out what it does. I want you to be able to track each line of the program and figure out what the algorithm is supposed to do. Do you guys see the difference? Okay. And once you know what each line is supposed to do, then in the next class, you will have no problem understanding, okay, these are my basic blocks of constructing a program, and I know exactly what each block is supposed to do. All right, so I'll just start with a particular sample program, and I'm using LibreOffice, which is something that you should have downloaded for your current homework assignment and have it configured. So I'm going to do this one, and just for the class, I'm going to zoom in a little bit so we can see better. And we'll just use a particular example. But before that, I have to change. Oh, not this one. I have to change the. You might want to do the same thing too when you are doing your homework assignment. Go to Tools and then go to all the correct options. Because if you don't fix these things, LibreOffice will try to be smart and kind of mess up your homework assignment. It won't mess it up completely. It just won't look right. Okay, so you want to go to Options and keep Replacement Table, but for everything else, just uncheck it. At least for stuff that you do for this class, we only want to use the replacement table. And later on, we'll find out that even within the replacement table, there are certain entries that we don't want. Okay, but for the time being, we'll just uncheck all the other ones except for replacement table, and you will. If you don't do it, you will know what I'm talking about. Okay, you will see the visual effect like right away. Okay, so we'll just use a simple example here, and I'll use x, y, z as my x and y as my variables. So I'll start with x gets a value of 5, y gets a value of x plus 2, and then x gets a value of x plus times 2, and that ends my algorithm. Whenever I write an algorithm, I would also use one column for its line number. I know the row number in the spreadsheet matches exactly the line number, but I will still use one column for the line number. And this is my algorithm. I want to find out what this program is going to do. What are the values of x and y when this algorithm is all done? Some of you can eyeball this and say, oh, this is easy, right? I can figure out exactly what the end result is just by looking at the algorithm. Well, just bear with me because I'm trying to use this opportunity to show you what a trace looks like and the essential elements that I'll be looking for when I grade your homework assignment when I look at the trace. So this is the algorithm. And very typical of what I do, I use a different window to look at the trace. You can open up as many windows as you want on the same document. In other words, you can be looking at different parts of the same document by using different windows. And in this case, I just go to Window, click New Window, and now I have Untitled 1, :2, which means this is my second window on the same document. And very typical of how I use this in the class, I line up the two windows so that I can show the algorithm on one in the background, and then the other one I can use a new sheet to represent the trace. So I use sheet 2 to represent the trace of the algorithm. And once again, it helps to make it a little bit bigger. When we trace an algorithm, we need several columns, and each column has a special purpose. The first column is labeled line number. In other words, the entries of this column indicates where are we at in the execution of the algorithm. Okay, it's really just a way so that when you go back and look at the trace, you know that, oh, this row is the result of executing this line in the program. So that's our line number column. And then at least for the time being, we have one column per variable. We have two variables in this case. One is x and the other one is y. So those are the three columns that we need in order to trace this particular program. I'll mention this once now, but then I'll go back and look at this trace when it's done and then mention this again. When we look at a trace of a program, when you look at it vertically, it is showing you the history of a particular variable. When you look at it horizontally, you're taking a look at a slice of time. So that means at the end of executing this statement, these are the results. Okay, each variable has those specific values. So I'll mention this again when we're done with this. The first line, in the trace is not line 1. The first one is what I call pre, which stands for precondition. In other words, of the entire algorithm, what assumptions can I make of x and y? What initial values can I make? What assumptions of initial value can I make about variable x and variable y? In most cases, there are no preconditions. In other words, I'll just say, well, we don't know anything about the values of x and y prior to the execution of the program.
Do we run through 1, 2, and 3 multiple times? Is that what the trace did?
In this case, it's just once because it is just a sequence. So it just follows the order of the line number, 1, 2, and 3, and then we are all done. When we get into the concept of a loop, then we have the ability to go back to an earlier line and do something over and over again.
I was going to ask you, x starts out as 5, and then you store line 3 as a new value for x. Does that first value for x go away?
Every time you overwrite, every time you execute an assignment statement, you destroy the current value of the variable in order to store a new one. That's a good question. All right. Now, because I'm not telling you that we know anything specific about the variables, x and y, I use question marks in both columns to represent that fact that basically says, well, we don't know the initial value of x nor the initial value of y. The thing is, you have to remember x is a variable and y is a variable. They have some value already prior to the execution of this algorithm. I just don't know what they are. Okay? There is a big difference between does it exist or do I know what value it has. In this case, it's a ladder case. It's basically saying, yes, x is a variable, it has a value, y is a variable, it has a value, but I do not know what those values are at this point, prior to the execution of the entire pseudocode. Are we doing okay so far? Okay. Now we move on to line 1. Okay, what we do on each row is we write down the values of the value, singular, of each variable after the execution of that line. In other words, this particular cell, B3, is going to tell me the value of x after the execution of line 1. What do you think it is going to be? It's going to be 5, because we have a constant assignment statement. Whatever is on the right-hand side is used to update the left-hand side, so 5 is the right answer here. What about y? What would be the value of y after line 1 executes?
Still null.
It will still be unknown, okay? Because line 1 does not affect y. If it was unknown before, it would still be unknown at this point. So I'm keeping the question mark here because it is still unknown. And this is a little trick that some of you will find handy. If you don't like the formatting because it's taking up too much space, you can just highlight the columns. When you highlight the column, you have to click the column heading first, and you can use Control, when you click, to select multiple columns. In this case, Shift would work too because they're contiguous. And then you go to the border at the end of the selection here until your cursor turns into a left-right arrow thing, and then you double-click it. And it will automatically resize the columns to just what it needs in order to display correctly. It's a really nifty feature, because that way you can keep your spreadsheet, smaller, and it's actually easier to read this way. But getting back to the trace here, we move on to line 2. This is the concept of a sequence. After line 1 executes, we move on to line 2. After line 2, we move on to line 3, and so on. At this point, we don't have the ability to continue execution somewhere other than the line below that, okay? When we get to conditional statements and loops, then we'll find out, oh, there are ways to change the path of execution. It's not always in one direction. All right, so after line 1, we get to line 2, and then we have to fill in each cell of this row. What do you think would be the value of x after line 2 executes? 5. It'll be 5, exactly. Okay, because it was 5 before, and line 2 does not change x in any way, so x will still end up with a value of 5. What about y? 7. It will be 7 because 5 currently has a value of 5. 5 plus 2 is 7, and then we use 7 to update y, and y becomes 7. Very good. And line 3 is the only one that is semi-tricky. But it's not tricky if you see this as, oh, okay, it's an assignment statement. There are 2 steps I need to perform. Step 1, evaluate the right-hand side. Step 2, update the left-hand side. The asterisk symbol here is multiplication. There's no multiply symbol nor divide symbol on the keyboard. So instead of changing the keyboard layout in order to make that happen, programmers typically, or programming languages, typically use the asterisk symbol to represent multiplication, and then the slash symbol to represent division. Okay, so in this case, it's a multiplication. So given that, what do you think I should put here in cell B5? 10, exactly, because x has had a value of 5 before line 3. So 5 times 2 is 10, and then we use 10 to update the left-hand side, which turns out to be x. So x now has a value of 10. What about y?
7. Same.
It keeps its value of 7 because line 3 does not concern y. Now we are done. I use post here to indicate this is the end of the entire trace. It's just like, for those of you who have taken math classes where you need to prove something, it's the same thing as a QED, at the end of a proof to indicate we are done here. This is the post condition of running this entire algorithm. So the post condition in this case is x equals to 10 and y equals to 7 when we are done with this algorithm. Are we doing okay so far in this? Yep.
You said it wouldn't matter if we switched the order.
In this case, it would, wouldn't it? Because in this case, if I switch line 3 and line 2, that will change the result. And that's why in this particular case, being a sequence is significant because the ordering of the operation is important. Are there any questions at this point about this trace? Because you will be seeing and doing this kind of traces for the entire semester. No questions? Okay. So are there any questions about, how are we going to execute pseudocode when the computer is not going to do it? Well, guess what? We are the computers in this class. We are going to run the algorithms and the programs. Yep. All right, excellent. I'm not going to save it, because the recording is still, let me double check, the recording is on. So, when I upload this onto YouTube, you will be able to view the entire thing. So you can replicate this if you want to, on your own spreadsheet. And I think it's a good experience too, just to replicate the process, because that way you get to know the tool itself, LibreOffice Calc as a spreadsheet program. And it's just, I think it's good exercise. And for those of you who are curious, okay, you want to say, okay, but what if this happens? Just go ahead and exchange line 2 and line 3. Just flip those two statements and see how it would change the result of the entire thing. Okay.
It will change y to 12. It will change y to 12.
Yep. No, x will still be 10, but then y will become 12. Yep. But you have to kind of go through the process and use the trace process, just so that you can visualize the whole thing. Now, I promise you that I will mention this again, to explain how to look at a trace. So if you look at column B as a whole, it is the history of the value of x being changed throughout the execution of this entire algorithm. So it starts out unknown, becomes 5, stays at 5, and then becomes 10, and then we are done. When you look at a spreadsheet like this horizontally, like this slide, this part here, it is a slice of time. It means when we executed line 2 here, at the end of that execution, x ends up with a value of 5, and y ends up with a value of 7. So that's how you look at a trace. It is a complete historical record of the states or the values of each variable throughout the execution of a program. Do you think this technique may be helpful in programming? It is not helpful when everything is going in the right direction. It is helpful when something goes wrong. Because if something goes wrong and you have a complete trace like this, you can go back in time and try to figure out at which point of my program it is making the wrong decision or doing the wrong calculation. Unfortunately, this is not a tool available to any debugging environment. They all lack the ability to track variables. Okay? You can set up constructs in a debugger that kind of would do the same thing. It's called a watch expression, and then it can kind of give a historical record of the expression throughout the execution of the program, but it's not going to look like this. It's not in this particular format. Question? No? Okay. All right. So if you guys want to, I can save it into a folder for today, but I think this is a little bit simple and there's no need to save it. It's in the video anyway. So I'm not going to save this one. Let's put saving. And that's it for this particular document. So now we're going to move on to something a little bit more complicated, more interesting, which is our conditional statements. At this point, we have talked about only one type of program. It's a straight line. Okay, you have line numbers 1, 2, 3, 4, 5, and you have to execute those particular statements in that exact order: 1, 2, 3, 4, 5, and they're all assignment statements because that's the only statement type that we have talked about at this point. That's useful for certain simple stuff, but it's not very useful for complicated things. Okay, anything that requires decision making, this is not going to do it. Anything that requires repetition, this is not going to do it. So that's why we have to start to talk about conditional statements. And that's the explanation why we need conditional statements, because sometimes we want a particular algorithm to go in one direction and do certain things, but other times at the same point of the algorithm we want it to take an alternate path to do something else. Okay. Before we move on to talk about this, let me use my little whiteboard here and ask you this question: how do we find the maximum of two variables? So I give you a variable x, I give you a variable y. I want variable z to become the maximum of the two. Using only a sequence, how do we do it? That becomes pretty difficult, right? Because, okay, so how do we find the maximum of two variables x and y? Store the result. Just hold on 1 second here. Store the maximum in z. Okay, so go ahead.
You would have z with the arrow to it. X
Okay.
and y.
Okay, so we know that sometimes we want this, because if x is the larger of the two, or if they're the same, then we want this statement. But what if y is larger? Then we don't want to do this, right? In that case, we want to do that. But I cannot sequence the operation like this, because if my program is like this, then it's always going to change z to x, and then it will change z to y, which is wrong. Okay? So sometimes we want z gets x, sometimes we want z gets y, but what determines which way I should go? Comparison. A comparison. Okay? Very good. Okay. So I'm changing the way this is actually being presented, because what I want to do is I'll do a. Let me try this and see if it works. Because what I'm going to do is I'm going to draw a picture. So instead of talking about this in pseudocode right off the bat, what I'm doing here is I'm going to use a picture to try to represent the logic, and then we'll go back and take a look at. I didn't bring my Elmo, I didn't bring my overhead capturing device today. Otherwise, I'll be using a piece of paper and actually hand draw this. I think I can do this part here. This is not too complicated. I can do this. Okay. So to represent the logic that we want to implement, we have a path that's coming down. Okay, so assume everything is coming down. This is a trail map, and you can only go in one direction, which is from top to down. Okay. So at some point we want to be able to make a choice. In other words, sometimes we want to go in this direction. Other times we want to go in the other direction. And what we want to do sometimes when we decide to take this path here is the following. We want to say, oh, the maximum is x. Other times when we want to go in the other direction, we want to perform the alternate operation, which means y is the maximum, and we want to update z with the value of y. So here we have z gets the value of y. But after each side is done, we want these two paths to merge again in order to move on to the next statement. Are we doing okay so far with this picture here? Okay, I'm trying to represent the logic in order to find the maximum of x and y and update the value of z, so z becomes the maximum of x and y. Okay, We know that we cannot do this with just a sequence because a sequence means it's always doing things in a particular order. There's no way I can do it using just a sequence. We need something like this. What we're missing in this picture is, but how do I decide which way to go? And somebody already mentioned we need a condition, okay? We want to compare x and y, and the result of that comparison can tell us which way to go. Okay, so that means whenever we have a fork or a branch, we need to answer a question in order to figure out which way we want to go. Sorry? So we'll go ahead and change the field color here. We're going to have to take out the field color and that's it. All right. So inside this box here is a question. And based on the answer to that question, I can now determine which way to go. Okay? So the question is this. Is it true or is it false that x is greater than y? Okay, if that's the question and those are the operations of the branches, how should I label the left path? In other words, what answer will lead me down this path?
Yes.
True.
True, okay. And then the other one has to be false.
Yes.
All right. That's our conditional statement. Okay, a conditional statement has exactly all of these components. You come in through one path, okay, so there's only one single entry point to a conditional statement. There are two alternate paths, okay? One is, in this case, the true path, and the other one is a false path here. But in order to determine which way to go, you have to answer a question. Is it true or is it false that blah, 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 blah? Okay, that blah, 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 blah in this case is easy because it's just, comparing x and y and asking, is x greater than y? Now in this case, keep in mind that x is greater than or equal to y will work just as well because when x and y are the same, then it doesn't matter which branch it takes because they will give you the same result. Okay? The other part that you have to keep in mind is after each alternate path, the entire conditional statement has to merge to one single path in order to get out. In other words, from the perspective of a conditional statement, there's one entry point and there's one exit point. But in between, you have a choice to decide which way to go. Are we doing okay so far with this picture? What it is trying to capture, the logic is trying to capture. All right. And this is pretty much as I would use pictures in programming in this class. Okay, every time we see a new, what we call a control structure, in other words, it can alternate the path of execution, I'll use a picture to represent that logic because it really is a lot easier to understand the picture in this context. But after this, we'll switch back to pseudocode. So let's take a look at the pseudocode representation of exactly the same thing. And I would use Office Calc or LibreOffice Calc to do this because eventually I'm going to trace this algorithm. So I might as well do it here. And let me see if I can do a slightly better job resizing this screen and still be able to show the entire thing. And then use this screen to type the pseudocode here. Okay. So in terms of pseudocode, a conditional statement has the following structure. It has a line that says if blah, 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 then, okay? It has a label called else, which separates the two branches, okay? So in this case, this row here represents one branch, and then this row here represents the other branch. And in pseudocode, at least in my class, a conditional statement ends with the words and if. Okay? That part depends on the programming language. If you program in Visual Basic, and this entire syntax should look really familiar because that's almost exactly the same way as you do it in Visual Basic. In C and C++, not so close to the actual syntax of the programming language, but close enough that we can actually understand what it is. The then branch, okay, the first thing is, what do we do about the condition itself, the question marks? This is representing the question of the, of the path, okay? Because you have to answer the question before you decide which way to go. So this is the condition. In this case, the condition is asking, is it true or is it false that x is greater than y? Okay, so that's what we're going to put here. Right after the then and before the else, we specify what we want to do when the condition is true. So what do we want to do when the condition is true in this case? Z gets the value of x, okay? So z gets the value of x here, and in here will be z gets the value of y here. That technically is correct already, but in this class, I will use the right indentation. In other words, I put some space, leading space before, line 2 and line 4. And this becomes my conditional statement. So now we have the conditional statement. Oops. The application automatically resizes itself in a way that I do not want. That's okay. Now we can put these two side by side. Are there any questions about these two? On the left-hand side, we have the kind of pictorial representation of a conditional statement. And then on the right-hand side, we have the pseudocode representation of exactly the same logic. Are we doing okay so far? Okay. So there's no quick and easy way to remember, the pseudocode has this logic, other than just getting more exposure and actually studying and doing it. So to map the pseudocode representation, like this one here, to the pictorial representation here, just takes practice. To me, when I learned programming in Pascal, my instructor, my professor, never used a pictorial representation. He just kind of explains, okay, between the else and the then is the stuff that you want to do when the condition is true, and then after the else is what you want to specify when the condition is false. That's the way it was taught, but having a pictorial representation is helpful. Okay, so if there are no questions, I'm going to switch to the trace itself. Let's go ahead and trace this algorithm. In other words, we want to execute this algorithm line by line and then figure out what it is going to do. This is also a good opportunity to show you why sometimes a precondition is helpful. Because in this case, in order to trace this algorithm, we need an extra column. The extra column, I just label that comments. Okay? It's really useful for tracking things that cannot be reflected in the other columns. Okay? And I'll explain why in this case there are certain things cannot be tracked in the other columns. And then in addition to this, we still have line number, which helps me identify, this is the result of executing which line in the algorithm. And then one column per variable. In this case, we have 3. We have x, y, and z. The precondition is, I'm not going to say anything about z, because the purpose of the entire algorithm is update z so it becomes the maximum of x and y. So why do I need a particular value in z to begin with? Doesn't make any sense. On the other hand, x and y, this time, I need to give them some value, because otherwise I cannot perform line 1. I cannot compare an unknown quantity to an unknown quantity and know the result. So x and y, in this case, they need to have some sort of value to begin with. So we'll start with some specific value like 7 and 4. Okay? So this is one particular trace of this algorithm. Okay? Are we doing okay so far? In this case, why I have to give x and y specific values. Okay? And that's why the precondition line is useful in this case, in this particular example. So we'll start with line 1. Okay, line 1 is the beginning of a conditional statement. It is significant because it evaluates the condition, and the result of that can help me determine which way to go. Let's deal with the simple part first. Okay, at the end of execution, after line 1 executes, what will become the value of x? It doesn't change it, right? And about y, it doesn't change that either, and z will still be unknown. So that's pretty easy. For a lot of algorithms, there will be lots of conditional statements and stuff like that. So from now on, if I'm not changing the value of x or y, I can just leave it blank. Okay, if it is blank, it means it's not updated. Whatever value it had before will still be the same here. It's just a shorthand, so it's not tedious like what I have to do now. Okay, so that's the easy part. The other part about tracing a conditional statement is I need to know the result of the condition. After I evaluate the condition, what are the results? So I have to say x is greater than y is it true or is it false that x is greater than y? It is true because x has a value of 7, y has a value of 4. 7 is greater than 4 is true. Okay? So that's what this column is for. The comments column is useful in this case because it can help me keep track of things that the other columns cannot track. In this case, it's the result of evaluating the condition of a conditional statement. Okay, where should I go next? I should go to line 2. Very good. So on line 2, I have one assignment statement to perform, which is z gets the value of x. So if I use the shorthand, should I do something here?
No.
How about here?
No.
How about here?
Yeah.
What do I put here?
7.
7, that's right. Okay. And here's a trick question. What do I do next?
You don't.
5.
Well, 5 is ambiguous, okay? Because when we trace line 5, there's nothing to do on line 5. Line 5 is a marker that marks the end of the entire conditional statement. So when I trace an algorithm, unless there is something to do on a line, I don't represent it in the trace. So in this case, I don't trace line 5, and I just say I'm done after line 2. Okay. I know it seems like, oh, Tech, you're just being lazy and not indicate the execution of line 5, but that really is not the reason why I do not trace line 5. When we get to loops, okay, repetitions, then it becomes ambiguous. If we trace the end marker of a loop, then it becomes ambiguous. Do you mean we are getting out of the loop, or do you mean that we are at the end of one iteration and we have to perform another iteration? So I don't even try to trace, and if in this case, because I want to be consistent about, what lines I trace and what lines I do not trace. In this case, I do not trace that line. All right, so this is all done. Very good. And what I'll do is I'm going to do the same thing with another sheet and basically say, what if I change, so I'm going to erase this. This is sheet 3, so I still have sheet 2 on the other side. So we'll just go ahead and change the value of x and y a little bit, like that. And then we'll start the tracing again from the beginning. On line 1, we are not changing the values of any of the variables. So I don't even bother to say the value of x, y, or z, because they will all be the same as the line before. But what is important here is to indicate the result of the comparison. X is greater than y is false, okay? Now you also notice how we do not use yes, no, we use true, false, okay? Because I really want to emphasize in programming, we try to use the colloquial confirmation and negation of using yes, no. We use the logic values, true, false instead. So in this case, the answer is false to x is greater than y. Which line do I execute next?
4.
Line 4, very good. Not 3, but 4. Line 3 is okay, at the beginning of a semester, if someone says, oh, next line is 3, I'll just say, okay, I'll take it as an okay answer, but it's not entirely correct because there's nothing to do on line 3. The purpose of line 3 in pseudocode is a separator. Its purpose is to separate the then branch from the else branch. But other than that, at runtime, when you're tracing the algorithm, line 3 serves no purpose. And that's why we don't trace it. Okay, so now we skip all the way to line 4 because the condition is false. Should I do something here? No, because x is not getting updated. Neither is y. Z is getting updated. What should I put here? 3, because it's copying the value of y. And then what do we do here? Post, exactly. We don't trace line 5 because line 5, once again, is really a marker. It's just indicating the end of this particular conditional statement, and it doesn't do anything. And that's why I don't trace it when I run the algorithm. Are there any questions about this particular trace? No questions? All right. So we have conditional statements. We have a sequence. Let's switch back to the notes here because I do want to double check and make sure that everybody knows where we are in the notes. Okay. So let's go ahead and go look at conditions. This part here just talks about why we use the words true and false instead of the words yes and no. Okay, but you just keep in mind that in programming we use yes no, and I know a lot of flow charts use yes no. Okay, that's really not a good way to do it. Okay. All right. Let's take a look at this slide here. Okay, it's just a review of comparison operators. Are there any symbols here that does not look familiar to you? These guys over here. They should all look familiar. Okay. The only tricky part is there's no key on the keyboard to type in these particular comparisons. So when you write programs, it is conventional that when you want to express the comparison of greater than or equal to, you just use greater than followed by an equal symbol. Okay, that means greater than or equal to. When you want to express less than or equal to, similarly, you use less than or equal to, less than, and then the equal to represent less than or equal to. Not equal to is the fun one because it depends on the language. For those of you who are proceeding to take C and C++, cisp300 in your next semester, the symbol is exclamation point equal to, which doesn't seem to make any sense. Okay, but once you know C and C++, it makes perfect sense because exclamation point means negation, not, in C and C++. So not equal to is exclamation point equal to. But C and C++ and all languages derived from C are the only ones that would use this particular symbol. In Visual Basic, SQL, Pascal, and most of the other non-C derived languages, they would use this particular symbol instead, which is a less than symbol followed by a greater than symbol. Does that make any sense? Not equal to, less than, or greater than. Do they mean the same thing? They mean the same thing. Okay, very good. Equal to is just equal to. Most people will think, so there's nothing to say about equal to because I can easily find the equal to symbol on the keyboard. So what is there to say about the equal to comparison? Well, if you're programming in VB, in SQL, and other programming languages, you'll be absolutely right. There's nothing to say about equal to. But most of you are moving on to cisp300, then there's a lot to say about equal to. Okay? Because remember, in C and C++, a single equal to is representing assignment operation. You're evaluating the right-hand side to update the left-hand side. So that means comparison has to be something else. Comparison is something else which is confusingly similar to assignment. It is equal, equal. And then someone will point out and say, but they cannot appear in the same context because comparison happens inside a condition. And an assignment operation is a statement on its own. It has to be something outside of a condition. So if the two cannot occur at the same place, then it should be okay to use a single equal in both cases. We have been absolutely right if this is Visual Basic, which is the case where you have assignment statements, and assignment statements cannot occur inside the condition of a conditional statement. But you can, guess what? You can do that in C. In other words, the condition of a conditional statement can be an assignment operation at the same time. Okay? And that's why using a single equal symbol is not sufficient. You have to use a double equal symbol to represent comparison for equal to. All right? The worst part of this is, what if you accidentally use one equal symbol when you really meant double equal? When you really want to do a comparison, but you forgot about using double equal and you use a single equal instead, what do you think will happen?
Well, your code just won't compile.
Well, okay, that's one alternative. The other alternative is the code will compile, but it will do the wrong thing. Okay? It all depends on what is on the left-hand side of the equal. If what you have on the left-hand side of the equal is not something that you can update, then the compiler will catch it and say, hey, you cannot update that side of a single equal symbol. Then you are saved. On the other hand, if your comparison just so happens to have a variable on the left-hand side, then it will turn the meaning from comparison, which is what you want, to assignment, which is an update, without generating an error message. When you run the program, instead of telling you the result of a comparison, it will be changing the left-hand side instead. And it will still give you, quote unquote, a true-false result. Okay? And that part gets confusing. I don't want to talk about it in this class. I just want to emphasize the importance of using double equal when you want comparison in C and C++, and in Java and all programming languages derived from C. Because somebody, well, we have about 50 students in this class at this point. I would say at least 5 will be bitten by this one in cisp300. Yep.
So for the purposes of this class, which is preferred?
In this class, we don't use equal for assignment, so we are avoiding this problem altogether. But in the next class, this can become a problem. All right. So that is done. Logical operators, we'll talk about these later. Actually, we are already at the point where we are ready to talk about that. But before that, I'm just going to show you something that is already familiar. You have seen this before, haven't you? Finding the maximum of 2 variables. This is the exact example that I used earlier to explain the concept of a conditional statement. Same pseudocode. And if you scroll down, guess what? Same picture. I did not have to draw the picture on during the class, but I decided to do that anyway because I think when I'm drawing something, you guys pay attention a little bit differently than when I show a picture and then just kind of talk about what is in the picture. So that's why everything is already here. If you don't write down the stuff that I was talking about earlier, it's already in the notes. And besides, everything is going to be on YouTube at the end of today. So you can always watch the whole thing again. I think there were 3 watches of the previous lecture, and they were all from me. Okay, so don't leave just yet. We have 2 minutes. I want to tell you guys what to do to prepare for the next class. Okay, we are currently here. We're talking about conditional statements, and we'll be talking about loops in the next class. So if possible, I want you guys to read at least up to what I have covered today, and if possible, go ahead and read the loops portion, okay? Because that will really help you understand the concept when we are performing, when we talk about loops. Okay? And don't forget your homework assignment due on Thursday. I think I have added everybody to the class, where if you have requested, I think I should have added you. Right. Thank you.
When will you be doing any ads for the wait list?
It doesn't look likely because I just took a quick look today.
Is everything pretty full?
Yeah, because you can see that. Okay, I'm just double checking here. Okay, I can show you. See, people who missed the first class, They have dropped already. I have dropped these people already. In fact, I have to add one person back in because that person, just did not, just forgot. So, of the entire class, people who are in class already, nobody is missing except for people who missed the first day already. Now, of the entire wait list,